Okay, so yesterday, or 2 days ago, whenever we last met, we were discussing kind of the use of having an array list of human objects, right? Um, so here, let's remind me, see if we get it right this time. So last time you answered wrong. What does abstract? What does it mean for something to be abstract? We made the human class abstract. What are we trying to accomplish with that? Yep. It disallows us from being able to create an instance of the human class. So it's our mechanism for saying that we do not intend to create instances of this guy, right? He exists solely for the purpose of inheritance. And I kind of asked, well, why might we do that in general? You know, hey, what if we just know we're not going to use humans to create instances of that? Do we really need to use abstract? The short answer is no, we don't have to use it. We don't have to use abstract, but it has two purposes. One, he's not here today, but Zach Rohde pointed out that for other developers who might use our code, it kind of gives them a roadmap as to how we intend for our library to be used. Similarly, though, it's also kind of self-policing. I probably mentioned something about, you know, like we leave ourselves little notes and stuff like that so we don't screw up ourselves doing stuff around the house. So by making it abstract, it keeps us from accidentally creating a human instance, because that would never make sense for us. Well, so then we kind of segued into this idea of, well, could we create a array list capable of holding humans? All right, and so the idea was, I purposely tried to trick you, okay, by saying, well, can you have an array list capable of holding types of an abstract class, humans? Well, at first you might say, well, no, it doesn't make sense because we can't create instances of humans, so we would have nothing to put in there. And we don't have humans to put into this array list of humans, so it's always going to remain empty. Well, but the reality is we have this abstract class called human, and I made it red, letting us know that you can't create instances of it. But we have two guys here that inherit from human, manager and player. Both of these guys have an is-a relationship with human. So a manager is a human. A player is a human. So we could store both managers and players inside of an array list capable of holding humans. Make sense? So now we have this container. We go back to the when we first learned about normal arrays. We said arrays were, and even array lists up to this point, were capable of holding like type values. So we could hold a whole bunch of ints, or a whole bunch of chars, a whole bunch of booleans, a whole bunch of strings, okay, like types. Well, now I have an array list that can hold managers and players. Two different kinds of types, because they share a core type of human. Does that make sense? So any questions on that concept before I introduce the instance of? All right, so now I'm going to trick you. Always fair warning. It's like Houdini, right? All right. I want to store I want to have an array list that can hold strings, managers, and players. All three of those kinds. Can I put those inside of team? This guy right here? Okay. I get a yes and a no? Okay. Tell me why you're wrong.
I guess I missed something. I thought they were all humans.
String is human?
Oh, string. No, sorry.
Or is it because I drew it where I drew it?
Yeah, it was for you.
Yeah, okay, yeah, no. This is our normal plain Jane string class. Normal plain Jane string class. Okay, you know, where we have the char at and the index of, that guy. Okay, I want to store strings. I also want to store managers, and I also want to store players. Can I store those in this array list built for holding humans? I can't, because string does not have an is-a relationship with humans. right? We're good with the manager and player part, but not with the string part. But I still want to be able to hold all three of those types. I want to create a structure. I want to create an array list that's capable of holding strings, managers, and players. How would I do that? Based on what you know right now.
Can't you just say array list object?
Yep. So we could do something like this. And actually, if I don't do the specifier here, that's the default. An array list of objects. Call this guy blah. Array list of object. All right, so this guy right here now can hold anything that is an object. And if you remember, well, we have it right here. So a human is at its most generic case an object. This comes with Java. This is the top level. I am the minimalistic class that makes something an object. Basically, it has the crap in it that works with the new keyword to get a memory address and all that stuff. Okay, we don't have any control over this this class. Okay, so under the hood, all these things are objects. So if we were to kind of draw the line here, we would say a string is an object, a human is an object. All right. Managers are humans, managers are not strings. Okay, so managers are humans, which are objects. So since string, manager, and player are all objects, we could store them inside of an array list capable of holding objects. Make sense how that works? Okay. Now this is a little convoluted because it's like, well, in what scenario would I want to hold strings, managers, and players? Things start getting a little weird there, but at that point it's like, hey, you know, a real life example might be you have a room that has, you know, a whole bunch of stuff all over the floor and all sorts of different stuff. I got my Teenage Mutant Ninja Turtle toys, I got my airplanes, I got some clothes, all sorts of different things, right? And I'm going to throw them all into the same bucket, just a container for holding stuff. That's what this would kind of be. You create a array list of objects that can just store anything that's an object. Now, the usefulness of that becomes, you know, it's less useful just like it would be in real life. If I want to know where my Teenage Mutant Ninja Turtle figures are, and they're at the bottom of the bucket with clothes piled on top of it, this might be hard to find, right? You know, I might not recognize, I might walk past that a bunch of times and not find the turtles. So in any case, just because we can do something like this doesn't mean it would necessarily be that common of a thing for us to do. Typically, we want to hold specific types. All right, so typically we might have an array list of managers or an array list of players. But in this scenario, we're thinking about a soccer team. Kind of makes sense that the members of a soccer team are the players as well as the managers, right? Those are all part of the team. Okay, when they hand out the in baseball, when they hand out the World Series rings, all those people get the ring. Do you like who all gets the ring for like a World Series thing? Is it players and managers? But how far down does it go? Like, does it like water boys and stuff? Do they get it?
You can like even get a ring if you're on the team for more than half the season and then got traded.
Really?
Yeah. Well, it depends on the league, but like the NBA, for example.
Yeah, like those guy last NBA finals who got a ring either way.
Yeah, they were talking about whether or not.
Oh, because he was on both teams?
Yeah. They were talking about whether or not he would take it if he was on the actually losing team, but still, would have been crazy.
I would. I mean, at least it makes a story. You don't have to like lie about it. You say, look, there's a story behind this. I mean, we lost. I won. That's actually interesting. Do you remember which player it was?
It was very Java.
So he was, he started on Golden State and was traded to Cleveland.
Other way around.
Other way around?
Yeah, Anderson Varejao.
Still very surprising that series went that way. I mean, did anybody see Cleveland actually winning that series?
I wanted.
No, I didn't really care, but I mean, you didn't really see them winning the series to begin with, and then once they're down 3-1, you had to have written them off. Who
Yeah.
didn't write them off? Yeah, that actually kind of like messed up my whole sleep schedule on my vacation because I was in Israel during the NBA Finals. They're in a little bit different time zone, so like games were like at 4 in the morning. So it was, but very entertaining, anyways. All right, so we probably would not do something like that, but we could. All right. So now what's going to happen here is as we put things that are humans into this team array list, they're going to go in as generic humans, which means they'll also come out as generic humans. So when I say get me the element at bucket 3 of that guy, it will come out of there as a human. Now I need to determine which type of human it actually is, because I know that it's not just a generic human, right? It might look like one, but it can't be because we can't create instances of humans. So it can't be just a generic human. It has to be one of my human types, all right, either manager or player. So we need to be able to ask what kind of thing was this. Let's go back into our code here. All right, so we went in last time we created this manager class that also extends human. We have our abstract human class, and humans have first name, last names, and a type. All right, because we were starting to try to figure this out. So we said that for a human, we can set the type to be generic human. For player, we'll override that type by calling it player. Now, what am I doing right here? What's that guy doing? Calling the what about the parent class? Which aspect of the parent class? Okay. No, I mean we're building something here. We are setting up those characteristics. But what's this guy actually calling? The constructor. It's calling the constructor of our parent class. So our parent class here is human. This is calling my parent's constructor. I'm passing it in 2 strings because we see that first name is a string and last name is a string. So if I go over to the human class, I would expect to find a constructor named human, because constructors always match the same name as the class, that takes 2 strings as a parameter. Otherwise, this is an illegal line of code, right? So I'm going to expect to find inside of human a constructor that takes 2 strings. So there's human, there's my constructor that takes 2 strings. Make sense? All right, so this line right here, which has to happen, well, it's got to be the first logic line in your constructor. I have a comment that came before it. That's fine. This doesn't get executed. But this guy is calling upon the parent constructor to do some initial setup for player. Because players are humans, we're going to go ahead and rely on the constructor for human to do the starting point setup, and then we'll further differentiate this player from a human. Does that make sense? And part of that is we are changing one of the values that the constructor, the parent constructor, set. So that's why this guy always has to come first. We'll allow the parent constructor to do the initial setup, and then we will differentiate ourselves from there. Part of this initial setup for human, we take in the first name and last name, we set the first name to the first name, the last name to the last name, but we also set this variable called type equal to human. Okay, kind of letting us know that this guy is a generic human. So after this call to super here, first name, last name, and type have already been set. We then go and modify type to make it be player. Does that make sense? So, because this is a player, not a human. So even though type was already defaulted to human, we're going to change it to player. So that's why these 2 lines can't happen in a different order. Otherwise, we would have broken our logic for player. We would have changed the player's type to player, and then when we call the parent's constructor, it would have flipped it back to human, which then makes it wrong for us, right? Okay, so then we'll set the jersey number and the skill level for this player because that's what differentiates a player from a human. We go over to the manager side. We went ahead and we're calling the parents constructor. We probably also want to then say this dot type is equal to manager, like that. And then we'll set the salary. Right now we just made all their salaries 100,000. This is soccer, so it's probably not in the United States. So this is another country. Let's see, 100,000 rupees maybe, which I don't think that like buys a candy bar, I think, right? I don't think 100,000 rupees is a lot of money. Yeah, I'm almost positive. I had one of my grad students last year gave me some Pakistani money, and it had some big number on it. But apparently he said that would like barely buy a candy bar. Or maybe he said it wouldn't even buy a candy bar. It was maybe equivalent to like a nickel. So I kept my hand out. So let's keep the money coming.
It's like $1,400.
Is it?
Yeah.
In rupees.
Yeah.
Huh.
1462.
Well, see, that's not bad. I mean, I don't. Would any of you work a full-time job for $1,400 a year? I guess depends how desperate you are, maybe. That's pretty low paying.
Maybe it's part-time Little League soccer.
Oh, I guess that's true. Yeah, kind of like the choir director at a small church. Yeah, same thing. Okay, so that's what our managers are going to be right now. So, and let's see, did I start putting this somewhere? Because we're kind of like hijacking our project here to do this. So let's go inside main activity, and we'll do onCreate. So inside of onCreate, let's just go ahead and we'll hijack this guy and we'll create our array list of humans and let's fill it up with some stuff. Okay. So I'm going to go ahead. We're going to say array list of human. We'll call this guy team. And we're going to go ahead and import array list. This guy's going to be a new array list of human. All right. So now we have an empty array list capable of holding things that are human objects. We have the ability to instantiate two different types of human objects, players and managers. All right, but we cannot actually directly instantiate normal humans because normal humans it's an abstract class. All right, so let's go ahead and let's so we haven't used the random number generator in a while, have we? Let's practice with that a little bit more. So we're going to say random r is equal to new random. And go ahead, it's in java.util. So we'll get our tool for generating random numbers. And now let's go through and let's just fill up our team with 100 humans of random types. Okay, so I want to do something 100 times. So for int I is equal to 0, I is less than 100, I plus plus. Okay, now each time I want to randomly either build a manager or I want to randomly build a player. Okay, so effectively we're flipping a coin, and if it's heads, we'll build a manager and put it into the array list. If it's tails, we'll build a player and put it into the array list. How can I int my random object here to flip a coin, if you will, based on what you know? Remember, this is the stuff like next int, those guys. Remind me, what does the next int method do for the, there exists a method in the random class that returns an int called next int and takes no parameters. So this is the header for that. Is that a class method or an instance method? Don't get this wrong. So I have that's the method definition. We're looking at the method definition of next int. Is that a class method or is that an instance method? And how do you know? I think it's an instance method. Why? Because of who? Because of the next? Okay, you're right with the instance method thing. The next part's completely made up. Yeah, you just made that up, didn't you? Yeah. yeah. Now that's just the name of the method. That has nothing to do with it. But this is an instance method. So can somebody tell me why we know this is an instance method? What do we not see? Instance methods always have what keyword in front of them? Nope, that's when we're creating an instance. Class methods always have static in front of them. The static keyword when we're defining them. This is the definition. So since this does not have static out front, it's an instance method. If it did have static out front, if it was static int, next int, that would be a class method. We call class methods using the name of the class in which the method was defined. We call instance methods using an instance of the class in which the method was defined. So if I'm telling you that this next int method, which does not have static out front, lives inside of the random class, that means it's an instance method, and therefore we will call it with an instance of the random class. R dot next int. That make sense? Pretty important. This makes sense eventually. I think I complained about that in the midterm, that too many people missed it. It's like, all right. So we're going to call this guy 100 times. Now I want to simulate a coin flip. What does the next int method actually do? What kind of value does it return to me? What's the return type of the next int method? I have it written up there. It's an int. Okay, this guy returns an int. All right. Now, what's the range of all integers? What's the smallest integer that exists, and what's the largest integer, or the largest int that exists? Ints are a signed type, right? What does it mean for a type to be signed as opposed to unsigned? Yeah, signed means it can hold both positive and negative numbers. It's capable of holding the sign. Unsigned means it doesn't try to hold the sign, therefore it's all positive numbers, 0 or greater. So int is a signed type that holds negative numbers and positive numbers. What's the smallest, well, we can say largest negative number, right? What's the smallest number that exists in int on the negative side? So ints have a range of about -2 billion to +2 billion. So this is plus or minus 2 to the 31st power, because an int is a 32-bit number. Make sense? So when I call next int, I'm going to get a number in the range of -2 billion to +2 billion. Okay, now so that's what our tool does. We went into Home Depot. This guy was on sale. I push a button, he gives me some number between -2 billion and +2 billion. I want to use that tool to emulate a coin flip. Should I create a player or should I create a manager? How can I use this tool to emulate a coin flip? How can I massage that value, or how can I utilize that value in some way to emulate a coin flip? This is just problem solving. You know, I'm asking you to be MacGyver. Go ahead.
Divided by 2, and if it returns, since it returns value, if it returns not a 0, you know it's off, even off 50/50.
Okay, so you want to look at the remainder. Okay, so you want to take whatever the number is, you want to divide it by 2 and look at the remainder. So we're going to take the modulus of it. Okay. So you're going to say even numbers are create a player, odd numbers create managers, something like that. Okay. What happens if we try to take the modulus of a negative number? What's -4 divided by 2? -4 divided by 2 is -2. What's the remainder? -4 mod 2 is what? Remainder be 0. So this will work, right? All right, so that's one way we can do the coin flip. We can use modulus. We don't have to make sure it's the absolute value or anything first. We can use it with negative numbers. Okay. How else can we do this? Okay, and well, so how are we going to get our Boolean? Yeah, I mean, we got this tool sitting here. I just can keep pushing the button, and what keeps coming out of this tool is a number between -2 billion and +2 billion. Okay, we have one mechanism for doing the coin flip. Is there an easier way of doing it? Go ahead.
Can we just say if if the hint is greater than 0, then set it to
Yeah.
player?
We've got positive and negative numbers. If it's a negative number, maybe if it's 0 or smaller, we'll give one of them is going to get the 0, right? So if it's 0 or smaller, actually, who should get the 0? Because we have it's actually going to be -2 billion and some change. So if we deal with a byte type, it's -127 to +128. So if we really want to give it as close to a 50-50 shot as possible, we should say 0 or less or greater than 0. That make sense? All right, so we'll go ahead and we'll get a number. Int num is equal to r dot next int. Then we'll say if num is less than or equal to 0, let's create a player. So we'll say team dot append. Isn't it append? Or is it add? Oh, it's add. Oh, append is Swift. This is going to be new player. And players take a first name, last name, jersey number, and skill level. So let's say the first name is F name concatenated with I. The last name is L name concatenated with I. Jersey number is just I. And skill level is I times 2. Just use the values that we have there. Okay, so that's if it's less than or equal to 0. Otherwise, if it's greater than 0, we want to create a manager. So we'll say team.add new manager. This guy takes in a first name and a last name. So this will be F name concatenated with I, L name concatenated with I. All right, so we'll fill up our array list with 100 random players and managers. Okay, now I want to go through that array list and I want to determine how many players and how many managers we actually have in there. It should be relatively close to 50-50. You know, we'll probably have more of one or the other, but you know, it should be in the realm. We shouldn't have 92 and 8. Okay, otherwise this random number generator is pretty crappy. All right, but we'll see. Let's kind of get our feel. So I want to go through. So we're going to have another list. It's going to be int I is equal to 0. I is less than. Actually, have I shown you for each loops yet? All right, well, I'll show you that as an upgrade to this in a second. So I is less than the number of elements in team, so it's going to be team.size, then I++. All right, so after we've gone ahead and filled our team, this happened somewhere else in the program for all we know. Okay, I want to go ahead and I want to count how many players and how many managers we have. So we're going to say int num players. It's going to start off at 0. Int num managers is going to start off at 0. Now I'm going to spin through here and I want to get a human. H is equal to team dot get at bucket I. So when I get something, let me just show you here. When I say team.get, notice this guy returns a human. I only put managers and players in there, but he always returns a human to me. Okay? So I'll go ahead and this will get the human that's at the particular index in our array list. Now I need to determine, is this human a player or a manager, and give credit in the correct place. And then finally, we'll just do a system.out. Num players. Here, let's say players colon concatenated with that. System.out.println managers colon concatenated with managers. All right, so that's what we'll ultimately print out right here. Okay, and actually just for the sake of argument, just so it'll be easier for us to find in the console. How do I determine? So I want to put some logic right here. How do I determine whether this particular human is a manager or a player given what we have right now? So there's our human class. We keep track of first name, last name, and type. Here's our manager class. We add to that salary. Here's our player class. We add to the base human a jersey number and a skill level. How do we determine if a generic human is a player or a manager? Go ahead. Okay, so if it happens to have a jersey number and a skill level, it has to be that guy. So how do I test for that? Based on what you know right now.
You could make a call for that, and if it returns with an error, that you know it is not a player.
Okay, how do we test for whether something returns with an error? I mean, you're definitely taking the rockiest path here, but you're not wrong yet. We're off-roading for this test. How do we test for whether something has an error? I think I've introduced this.
You call it, and I remember there was a way you said, like, if something returns an error, you drop down this, but I don't remember.
Yeah, the try-catch. Try-catch guy. So you want to maybe do something like this. You want to try to say h dot, let's say jersey number. Oh, actually, we would have to say get. Actually, we made those guys protected, right? For player. Oh, we made them private, so we'd have to use the get. Okay. So get jersey number. Okay, we'll do something like that, and it's going to scream at us here saying it doesn't think that that guy's a real thing. So we're going to try to treat our H as a player. So we'll say, okay, you're a player. Let's try to get your jersey number. Oops, sorry. Then we'll go ahead and we'll say num players plus plus. And we'll catch an exception if something bad happened there. We know that the bad thing is going to be this guy right here, right? All right, so we'll catch that exception and we'll say num managers plus plus and then move on. So hey, I'll just assume you're a player, try to grab your jersey number, and then I'll add one to player. If something bad goes down in there, I'll catch the exception rather than let my program crash. And then I'll increment now managers instead because you must have been a manager then, right? Okay, so let's go ahead and run this and try this guy. Then we should get players and managers printed out there. So let's launch that. Hopefully the rest of our app was in a running state before. Yep. So here's our players. We had 55. There's our managers. We had 45. Feels 50-50-ish. Okay. Now, first of all, that was, well, we want to say two different things here. First of all, I really like that you came up with that solution. It's a horrible solution. But that's exactly what I mean about being MacGyver. All right, there's so much easier way we're going to do this. Okay, but that solution works. If you've seen the show MacGyver, now it's a new show, so you know. But MacGyver always he just builds stuff with crap. So let's say there was this one episode where he had to like kind of fly off this mountaintop or something. Okay, what he just did, he's in this garage. He needs to create something to fly off the mountaintop. He looks around the garage. He sees, oh, I got a lawnmower engine. I got some pieces of wood, and I have an airplane. I'm going to build an airplane out of the lawnmower, the lawnmower engine and these pieces of wood, ignoring the fact that there's a working airplane over here. So, hey, but it got the job done. So I like this solution. This is good. All right. So he said, look, I'm going to try to treat you as a player, whether you're a player or not. I'm going to try to extract your jersey number from that so-called player. Only players have jersey numbers. And assuming we get past this line without blowing up, we'll go ahead and add one to player. Hey, I guessed right. You must have been a player. Otherwise, we'll catch that exception, and we'll just say, oh, yeah, you must have been a manager. Move on with life. All right. Good. I like that solution. All right. Let's do it better. let's come up with an alternate solution. We'll comment this out, though, because that's a nice work of art to remember. Okay. See, that's going to be like one of those famous paintings where you look at it and everything's like upside down and stuff, and you don't know, why it's famous, but they're like really expensive. When we walk around the cruise ships and we look, they always have art galleries on the cruise ships. The ugliest paintings, the weirdest, they're the most expensive ones. See, I don't understand. They probably have an art appreciation class here, don't they? Have any of you had an art appreciation class? How are you supposed to appreciate like something that just looks weird?
All my high school art classes, we got to critique other people's art and say what you thought was good about it and what was bad about it.
Mm-hmm. And I mean, look, what do you come up with?
Most of the bad things.
Just, like, this looks ridiculous. I mean, you want to see good art? Look at my paintings I made on Facebook. Yeah. My wife takes me to these, I don't know what they call, like paint night or something. You go there and you drink wine, and there's like a professional artist up front that says, here's what we're going to be making. They have like the final painting. And then the professional artist takes you through the steps of creating that painting. At the end, my wife's usually looks, reasonably close, and mine does not. I go off script early. I draw Teenage Mutant Ninja Turtles on mine. They always say they love my painting, but I'm pretty sure it's because they assume I'm the one who's leaving the tip. And I'm also the one who's had, I just drink the wine right out of the bottle. They try to bring me a glass that's inefficient. I find that inefficient. Okay, so I'm going to call that, from an art appreciation perspective, a beautiful painting. And He spent hours on something he could have done in 5 minutes, but I like that approach. All right, so let's come up with a better way. Okay, what's an alternative approach based on the tools we have sitting in front of us for determining whether something is a player or a manager? Something a little bit more mainstream. Yeah, so all humans have a type. The default human sets the type to human. Players, after they let the human constructor do its job, change the type to player. Managers, after they let the human constructor do its job, change the type to manager. So we know that every single human has a type because we built it that way. So no matter what kind of human this is, where am I at? I can say if h dot type dot equals player, actually I want to do, you know what, it's actually, it will, yeah, I want to, so if h dot type, if the type of our human is equal to player, increment num players, otherwise increment num managers. Is this the correct way to determine whether the type is equal to player? You just saw me write something else a second ago. Let's start with this. Is this going to work? We have a couple of head shakes. Well, let's run this. And now whether you're right or wrong, I'm going to ask you why it did or didn't work. This is actually a very interesting problem. I hit play, right? Terminal. Oh no, it's not terminal. It's run. There we go. Just make sure that was the newer version of this. I don't think it's running through this logic again, so let me kill that. Launch it again. Okay, there we go, 4654. It appears to have worked. Now, this is not the correct way to write that. I'm going to comment that out, and I'm going to say if h dot type dot equals player, do this. That's the correct way to write it. We're going to run this. We're going to see that the numbers we get are going to be pretty similar. So even though I'm telling you it was the incorrect way of writing it, we actually got the right answer. So now my follow-up question is going to be, why did we get the right answer? So we'll see that this works as well. You know, it's a new random spin, so it's going to be something close to 50-50. Oh, I got to stop it and rerun it in order for it to run this logic each time. All right, so 5248. All right, so both of them worked. But I'm telling you that this is the wrong way to write it. This is the right way to write it. What's wrong with doing it this way? In this particular case, we lucked out and it worked. This particular case, we lucked out and it worked. Go ahead.
Isn't it checking if the memory address is the same when you're using
Yep.
that operator?
So this guy is the equivalence Boolean operator for primitive types. What it's saying is the value stored inside of type, which is a string, does it share the same memory address as that? The string literal called player. Does that make sense? This version is saying, does the string that's stored inside of type, is it equivalent to the string player? Is it the letters P-L-A-Y-E-R following each other, regardless of memory address? This is comparing the content of the strings. This is comparing the memory address of the string. Now, it just so happens we lucked out here because in this particular scenario, they do the same thing. And let me prove that to you. So we're going to go back to that version of the if statement, which we saw worked, right? But I'm going to throw a little curveball here. We're going to go into player. And I'm not going to just set the value of type to the string literal player. Instead, I'm going to set it equal to a new string out of the string literal player. What does new do? What's the new keyword? Go ahead. Okay, yeah, get brand new memory address. That's our real estate agent, goes out and finds a memory address. So before, we were always getting the memory address of the string literal player. And wouldn't it make sense if Java had previously seen a string literal call player? If you're just asking for that string literal again, would it create new memory for it? Or would it just go and say, oh, you mean this guy? Here's his address. So rather than storing player 50 times, it stored the player string literal once. Now we're saying this is a different string that happens to contain the same word, player. It's a different memory address. Similarly, here in manager, we'll say that this is a new string manager. Okay, so now when we built players and managers, for every unique player and every unique manager, we gave it a unique address to its string for type. That make sense? We didn't rely on that one string literal. So we come back into our code now here in main activity. When I ask if the type for that human is equivalent to player, we're saying, is this memory address the same as this memory address? What do we expect the output of this code to be? Go ahead. 100 managers. We should never find a player that matches the, whose type matches the memory address of the string literal player. That make sense? Let me think about this for a second. How it's going to work. No, it'll be 100 managers, like you said. At some point in there, the very first time through, it's going to go ahead and it's going to assume that that original address for player is that new string literal. But since we're creating new addresses each time, at some point we are going to get a string literal called player. We're going to say, oh, well, that's our player. Okay. But since every player creates a new string, they're all going to be different memory addresses. So let's run this. Zero players, 100 managers. Make sense? What if I go back to the other if statement that I said is correct? What should we get now? 50-50-ish thing, because now we're not looking at memory addresses. We're looking at the contents of the string. We are comparing this string to this string in terms of what the string says, not in terms of where the string lives. Make sense? Okay, so this will give us the correct answer regardless of how we built our player and manager strings. The other one, we just lucked out the first time, and it happened to give us the right answer because we took advantage of string literals. But that's a really important concept for us to understand because, as you might imagine, sometimes you're going to get weird behavior in a program where, from your perspective, you did everything right. And that might be a hard bug to hunt down. So I'm looking for equivalence here, and you don't understand where you went south. All right? That's why whenever you're comparing strings, unless you explicitly are interested in the memory address, unless you just know, I want to know whether this string and this string are the same physical string. They're from the same memory address. Unless you care about that, never use the double equal sign when it comes to comparing strings. Always use the dot equals method because it knows how to compare the contents of a string. It will never be wrong, regardless of how you built the string. Okay? So there's your 45, 55, something like a 50-50 split. All right, so does everybody understand that difference? That's a really, really, really important lesson. Because I promise you, I don't remember what year it happened in, but at some point, I spent a lot of time hunting down that bug. And now I'm able to share that experience with you. All right, so, which is, that's what's fun about programming, I think, is, you get frustrated and you find things and you go on this wild goose chase. And then as part of that, you get a deeper understanding of how this language is actually built. I find that fascinating. Maybe you're more of a Team Fortress. Is that still a game, Team Fortress? It's still a game, right? Isn't that like the competitor with Blizzard's shoot 'em up one? They're like similar, right? Kind of.
I don't know. I think that like Team Fortress doesn't attract new players as much as it just keeps the people that have been playing it
I see.
forever.
I've heard the Blizzard first-person shooter is like good. Is it? Have you played it?
Schumacher plays it a lot.
Well, Schumacher, that's all he does is play games.
I don't know if he likes it a lot. He told me to play it, but I haven't.
Yeah. He wants to come over and live stream me playing Skyrim.
He told me.
He got me to buy the new Skyrim with the new graphics. I've never played the original, so I don't know what I'm doing. So he thinks it'll be funny to videotape me not knowing what I'm doing, and apparently getting killed by you. I think you drain the souls of dragons and stuff, which I find exciting, but apparently it might not go so well the first time I fight a dragon. Is what he's kind of speculating, and he wants to get that on tape.
The first dragon is hard to beat, though.
I'm pretty bad at some of these things.
Let's see.
I almost beat a 9-year-old in Wii Madden football at Thanksgiving. I couldn't figure out how to pass. Have you played Madden football for the Wii? Passing is made up, is it not? I mean, you're supposed to you're supposed to pretend like you're throwing. It's made up. It's not a mechanic. Half the time the guy wouldn't throw the ball because I was too tall for the sensor. So I had to just do run plays. I did pretty well with the run plays, as long as I just hold on to the ball. So I almost beat him that time. It was a barn burner. It came down to the final possession. Okay, so does this make sense when you're comparing strings? Unless you specifically care about the memory address of that string, always use dot equals for comparing the string. There's also another one called type dot equals ignore case. Okay, that will allow you to compare two strings disregarding capitalization and stuff like that, if that's of interest to you. So we have two versions of comparing the contents of a string to another string. Okay, so important concepts there. All right, so this is version 2. of our code. Okay, so now what we're going to do, and we're going to call this a significantly more elegant and more planned solution to it, but not nearly as MacGyver-ish as the piece of art we have down here. Okay, I'm really impressed by this. This is like a star for the day. No, really, most 250 students would not have come up with this. You should be kind of ashamed and proud at the same time. Because you might need a quirky solution like this for something at some point. So having an understanding of this is, I think, a really good thing. All right, and hey, it got the job done, so who cares? But now what I'm going to do is we're gonna break stuff. Actually, what we're going to do is we're going to break the more elegant solution. His solution will keep working. All right, so we're going to take out the type here. So why should I have to store the type with my objects? A human is a human. A player is a player. A manager is a manager. Do I need to really let them know what their types are? They already have a type. So we took type out of human, which means that we're going to have some errors in player and some errors in manager because we no longer have types in there. There's my manager. Okay, so there we go. So type is now gone. So if we go with this solution, notice it screams at me. It doesn't know about a thing called type. So that solution no longer works. But guess whose solution keeps trucking? It still works. Run it again. So it's waiting for some process to come online. Let's kill it. Is it killed? And run it. There we go. 4456. Still cooking. All right. So not so bad of a solution now, is it? Yeah. Your elegant solution broke down so quickly. Okay? But this quirky thing holds up. But we're going to still say, you know what? In actuality, let's go this route. This will be further complimenting him, actually. What do you think is the real problem with that solution? So this is our art appreciation. If you're critiquing this solution, what's the real problem with that? Oh, that certainly would have broken. But in this case, it works. I'm saying, given that this works, what's wrong with this code? How many of you would have followed this code had I not explained it? It's weird looking code, right? You know, it's kind of funky what it's trying to do. Right? I've been doing this stuff for a few minutes, so to me, this is an interesting solution. But for most programmers, this isn't really easy to read, is it? This code up here is pretty straightforward, isn't it? Hey, if the type is player, you're a player. If it's not, you must be a manager. That's easy to read code. It makes sense to the average developer. And this doesn't mean, if you don't know what this guy down here means, doesn't mean that you're stupid. Okay? Because, I mean, all programmers have had different collections of experiences, right? I mean, so I've been doing stuff for a while, but if there's some mathematician that writes some like combinatorial mathematics solution to something, I'm going to have trouble following it. Because it's like some made up math that sure works, but I don't know what it's doing. Okay, it's a solution that isn't familiar to me. Right? So when somebody looks at this, there's a good % chance that somebody's going to look at this code and say, I don't really know what that's trying to do, even though it does work. That makes sense? So if we kind of go off what Zach had said last class, he mentioned that one of the things that we do need to be aware of is that somebody else might be reading our code. Now, if you know that you're the only one who's reading the code, and he couldn't come up with the more elegant answer, and he's saying, look, I just need this thing to work now. MacGyver got out of that garage on the airplane, right? For all we know, the other airplane didn't have gas, and the lawnmower did, right? And chances are a real airplane is going to take a lot more gas than starting a lawnmower, right? All right, so the real problem with this solution is that it requires maybe a deeper understanding of how a try-catch works. You know, it requires that you understand that when this line fails, it never gets to this line. When this line fails, that error is caught right here, and we do this instead. Does that make sense? So it does require some structural understanding of how these things work, which isn't necessarily a hard thing, but I think you will find that many professional developers, people who've been out of school for 2 or 3 years, let's say, would look at this code and not be confident what it does. So it's quirky. So it's quirky code. So having said that, we removed the type from this guy. So now we can no longer use our easier to follow solution up top. Okay, we've chosen, okay, not to use our awesome solution down here. So we want to use a more elegant solution, but based on something new. Okay, last class I said I was going to introduce an operator to you called instanceof. So what we'll do here is we'll say if H is an instance of player num players plus plus else num managers plus plus. This is pretty much the identical code that we wrote right here. But rather than us provide this special variable called type to determine the difference between these guys, we decided to go ahead and take advantage of Java's built-in Boolean operator called instanceof that allows us to ask the question, is this dude one of these dudes? Instanceof returns true if H is in fact an instance of player. Does that make sense? Otherwise, it'll return false. So let's go ahead and run this. So instanceof is a Boolean operator, but for object types. It only works for object types. So don't try to say 5 is an instance of int or something like that, because that's a primitive type. Stuff's going to zig when it's supposed to zag, and then there'll be an explosion, and it won't really matter what you built your airplane out of. I like to see, as I keep using these like metaphors, how many people I start losing as class goes on. Like, this guy's so hung up on MacGyver. The original MacGyver is so old now, too. Is it Dean Anderson? I think it's his name. All right, this thing launch. He was Colonel O'Neill on Stargate show. You've seen Stargate, right? Love that show. Except Stargate Atlantis sucked. I didn't like that show. All right, so there's our 4555 using instanceof. All right, so we all agree, now that we know what the instanceof operator does, that this is pretty easy to follow logic for anybody who's a programmer, right? We could follow that. Reads pretty nicely, saves us some even more time. We don't have to throw this stupid type variable into our objects to try to keep track of them ourselves. Because that was kind of like us slapping a post-it note on everything, right? Like this guy's actually a player. This guy's actually a manager. Now it's like, why don't we just use the built-in mechanism for comparing these things? All right, make some decent sense. All right. So now that we have our players and our managers, the ability to store our players and our managers, what might be the next step in terms of our application? So we come out here. We have the ability right now to add a player. which brings in all the information about players, jersey number, skill level. We can add a player. Might we also want to have a button for add a manager down here? Okay, so go ahead and throw that button in there. I'm lost. Layout, main. I tell you what, this interface builder for Android is just so much better than it used to be. You have no idea how bad this used to be. All right, so there's our ad manager. And we're going to have a add manager activity. So we'll go ahead and right click on this, new activity, basic activity. Actually, sorry, empty activity. That's what we've been doing, right? And we'll call this guy add manager activity. Activity, like that. Okay, now we'll go back to our main activity. And we're going to duplicate this handler for our button press, for add manager button pressed, and this guy is going to launch our add manager activity class, and then we'll start that activity. So let's get into our add manager screen. So this is what add player currently looks like. I'm going to go to the text of this guy. I'm going to go down to my linear layout here. Copy everything from my linear layout. Open up add manager. Go to the text. And I'll go ahead and paste that guy in there for now. Go back to design. Okay, so when we add this is going to be adding a new manager. Managers will have first names, they'll have last names. Now, for us, we can choose to put in a salary. Our code currently hard codes the salary, but let's go ahead and let's call this guy salary ET. We'll call this salary. We won't have a skill level associated with that. And it's going to be add manager for our interface there. All right, so when we add a manager, we're going to have the first name, the last name, and the salary, and that should add a new manager to our team. All right, so for your homework, you're going to be writing the logic for this screen, the add manager screen, and then you're going to be updating the logic on, let's just go back out here. When I say add player, we'll say Mike Littman, jersey number 1, skill level. We decided infinity was a hard number to write, so we'll just do add player. And that comes back and it adds the player there. All right. What we want to do is we want to modify our roster here to show all the managers first, then show all the players. Now, what's going to be interesting about this is if we come out here and I go into our main activity, actually we do that on when a player is added, right? So it's actually in add player activity. So this is where we create our player. We put all the stuff in there. We create our new text view, and then we grabbed the player list from our singleton and added something there. Well, in our case now, we want to remove all team members from the list, then re-add them given this new player. That makes sense? And the way you're going to accomplish that is you'll say core.playerList, which is a linear layout, dot remove all views. So that will dump everything from it. But then what you'll do here is instead of just adding a single player, this text view to that guy, you're going to have to loop through all of our player objects and re-add each of those guys visually to that list on that main screen. Does that make sense? That way we can maintain a thing on our main page that shows managers first, then team members. All right, make sense what I'm asking you to do? So code the logic for add manager, and then make the list on the main page always show all the managers first, all the players second. Got it? All right, I will see everybody on Tuesday.
That conversation on comparison operators helped me realize what I was doing wrong for something for another class. I always do that one. I don't
Good.
know why.
Well, it's because you're inexperienced. And as you get more and more experienced, the problems you run into will become even more infuriating. Well, you'll start getting mad at the implementers of the language, like, well, why would they do that?
I had a method that was doing a recursive call to generate a random number.
Yep.